The next topic is Malio teaching a machine to detect malware. The presenter is Toni Grzinic. About Malio. Malio is a machine learning framework that successfully detects new malware samples. Despite the fact that malware is constantly changing and non-stationary malware distribution presents a challenge for statistical methods due to the phenomenon of concept drift, Malio helps to overcome these problems and can help to better detect new malware samples at large scale. About Toni. Toni is helping organizations to become more secure, working as an information security consultant in Diverto. Besides that, he managed to write his doctorate thesis. Also, Toni will be performing music at the after party.
So the talk will be short. I will not take any questions because we have to prepare the after party. So I'm Toni, and I will be talking about Malio. Malio is a machine learning framework to detect malware. It basically detects only portable, executable malware. This is my agenda. This morning I didn't have any slide. I built all slides when I was listening to the politicians. So the talk is not prepared, so stand up and enjoy. Back to 2014, I was trying to write my PhD thesis and find a topic. Basically, I was trying to detect anomalies in time series. I was analyzing logs, and I have a big problem. RDD, I was working at Carnet, and basically I had a lot of data. It was cool, and I was doing math, which I love, but I have one big problem. The biggest curse of big data is when you don't have enough data. The Carnet NOC, the Network Operations Center, was on summer holidays. I didn't have any data. The annotation of the dataset was painful. I was waiting for the attackers to attack our network, to annotate the dataset, and to learn my models. So I have so much problems. So I was talking to Tonimir. Tonimir is my mentor on the PhD thesis, and he said to me, I don't know, it's your problem, be creative. So I changed the idea. At that time, Game Over Zeus botnet was disrupted, so I said, okay, that's a big thing. Let's see what we can do here. I was listening to the Endgame talk about Binary Pig. Binary Pig is a Hadoop framework to extract data from portable executable files. And I said, that sounds so interesting. And it's better than the anomaly detection thing because it doesn't have so much math, it's easier, and it's more sellable. So what problem I'm trying to solve here? So the problem with antivirus is the number of signatures. The antivirus companies cannot stand the competition with the malware authors because they're so creative. It's basically a catch-up game. So every year, the number of signatures goes up. It goes up exponentially. This is basically a picture for the Romanian CERT about the evolution of ransomware. So you can see it's so much samples, new things and stuff. But who is Malio? Who is Malio is basically, Malio is my grandpa. What is Malio? Malio is a framework, I said that earlier. Uses a bunch of classifiers to detect malware. So it uses the static analysis classifier, thanks to Eero Carrera and his amazing work, and the dynamic analysis, which is based on Cuckoo Sandbox. So I take different classifiers and I fusion it together. So basically, every type of analysis has some type of problem. Static analysis is bad for packed files, and dynamic analysis is bad for anti-debug and anti-VM methods. So when I try to combine them together, I get a better result. Basically, the data problem was solved pretty easy. Thanks to the guy from Twitter. Malio is great. It has many samples, and virus share is also pretty great. It has, I don't know, 100 terabytes of malware samples. Basically, this is my workflow of my framework. Basically, it used Cuckoo. It launched the malware file in the virtual machines. It stored the analysis result in MongoDB. The batch script, it's a simple batch script which runs all the analysis. And Franco, which is written in Python, does all the crunching. Basically, this is the storage one function, and this is the analysis one. It creates the matrices with the features. Then we learn the model, and when we have the models, we can classify the malware. It's simple. So I'm basically using only open source. I'm standing on the shoulders of giants. Basically the classic scientific Python stack. I'm using NumPy, IPython, Pandas, scikit-learn. I'm running the analysis thing in KVM. I mentioned Cuckoo earlier. And basically I use Mongo and Postgre for storage. At the moment, I have 3 classifiers. The first one use only static features. The second one is dynamic, which use some system calls properties, like arguments properties. And the second one is basically a system call graph, which is basically a matrix of all system calls. Basically, the idea is based on one idea with one great scientist. It's called Wolpert. Anybody heard about Wolpert? He wrote about the no free lunch theorem. So he also wrote about the stack generalization. And basically, Marco talked about convolutional networks, deep learning. This is an old school technique from 1992. It basically uses multiple classifiers. It takes their predictions, uses a meta classifier, and gives us the final prediction. So the training data. The training data was derived from a big data set of 50,000 samples. It was stratified by year and by malware type. The malware type was derived by the antivirus Kaspersky. Thanks to Kaspersky. It helped me a lot. So let's benchmark Malio to others. This is my PhD topic, and I can show all the results. Basically, one guy who was working at the Los Alamos laboratory, now is in Cisco, was the best. It was my idol. And I had so much problem with that paper, and it wasted me a lot of time. So finally, he was the best one, but I managed with some transformation of data. It's not about the result. Machine learning in the scientific community, it's all about the results. If you want to have a good classifier, you have to have 99%. Basically, I think it's better to do a good idea that can classify malware and that's creative than to have a 99% result. Because you have to have a resilient classifier at the end. So some of the problems of this domain are the following. VM evasion in dynamic analysis. This was a big problem. I patched the cuckoo monitor function. Anyone look at the source of the cuckoo monitor function? Guys from Reversing Labs. I patched it a lot, and I have so many problems with that. Basically, the cuckoo monitor, it's not that bad, but malware authors are so creative in escaping sandboxing environments. So they are finding every day new ways to escape sandboxing. Also, this model has to have a human in the loop. Guys from Google, Scully and colleagues wrote about detection of spam advertisements. And they said without a human, without an analyst in the loop, you cannot detect, basically, the ads, which are malicious. Also, the temporal component. I had so many problems while finding some new ransomwares, putting it in the data set, and with the results were so bad. Basically, new malware drifts your distribution of data and it skews your results. So this is a big problem also. One idea, what I plan to do next is to build a phylogenetics tree of malwares. Basically, you have one branch like you saw on the Romanian cert picture. You have one tree with all malware samples and ancestors and stuff like that. So, future of Malio. I plan to support more formats for it, use disassembly and build another classifier which uses disassembly, provision it to the cloud, and change Postgre with some other technologies like ClickHouse is a Yandex database, column-oriented, I think. Spark, Dask. Basically, I'm benchmarking this together to see which suits more for my usage. This is my talk, so fast questions if somebody wants to ask me on, or you can ask me any questions on my email. Anyone? Yeah, you can basically, this is why I call it framework. You can extend the framework with any classifier you want. You build a symbolic execution classifier, and then you incorporate in the framework. The only problem is you cannot have many classifiers. When you go to 5 classifiers, there's a problem because you have to manage all that. That's the only problem. But it's one idea, not the symbolic execution one, but the dynamic instrumentation with pin and stuff like that. Yeah. Other questions? Okay. Thank you.